Okay, so I'm just doing a quick video on a register that I'm making for part of my DIY CPU, or my breadboard CPU or stripboard CPU, or however I'm going to do it. And you're looking at, of course, some flashing lights, because that's always the best way to start. This is my register, just a simple 8-bit storage register, and you can see the things that I'm storing flashing away there on that LED bar graph display. So there's not very much to this. There's just an 8-bit, an octal, a D-type flip-flop. So 8 D-type flip-flops in this chip here, which is the 74HC574. And in this chip here, we've got an octal buffer. So it's just 8 buffers in there, 8-bit buffer, 74HC541. And the data bus is connected to my 8-bit data bus up here, although it's not really, because what I've done is connect it to my trusty Arduino to pretend it's a data bus, because I haven't actually got a data bus at the moment. In fact, all I've got is a register, so there's not much. And what I'm doing is I'm making the Arduino set the 8-bit value into this register and then read it back. So what's happening is that the 8-bit, a random number basically is being generated on the Arduino. It's being sent in through this data bus here. It goes into the flip-flop. On the other side of the flip-flop, the outputs of the flip-flop are always enabled. Then they come to this bar graph display here. And then from the bar graph display, it flows through there. That's completely removable. Just put that in for diagnostic purposes. So that's what I've done there is I've soldered a single inline resistor pack, an 8-way resistor pack on the bottom of this it's actually a 10-way LED display. I'm only using the middle 8 of them, which is, I've tried to cover up the 2 end ones with a marker pen, and it's got a funny purple colour. So there we are, and so that plugs in there. So it's basically got 8 data pins coming in, and then a common ground pin at the end. So if I line up that common ground pin with that, there we go. We're back on. It's a bit wonky actually. Lovely. So I could actually have got away with just using a single octal flip-flop here and just store the data in it and return it. But I wanted it to be visual, so I've enabled the outputs of the flip-flop. So the flip-flop's just storing the number. It's being displayed here, the 8-bit number, and then I'm using this latch to loop the data back round and back onto the data bus. So data flows in through the yellow wire, into the D-type flip-flop. The outputs of the flip-flop come through the yellow wires round to here, through the buffer, and back through the white wires back onto the data bus and back to the Arduino. And the Arduino is running a program at the moment that's writing a random number and then reading it back again and checking that it's correct. And to do the writing, that is done by this right pin here. So if we pull that one out, it kind of upsets it a little bit. And the reading back again is done by this pin here. So if we pull that one out, it probably won't make any difference, because that is only telling the data to be written back to the Arduino. So so I've got an 8-way data bus here, and then I've got power and ground coming in here. And I've got 2 wires from my Arduino, a couple of other pins on my Arduino, which are controlling what I think of as publish, which is where the register publishes its value onto the data bus, and store, which is where the register stores its value. So that is a breadboarded 8-bit register. Let's take a look at the the data sheets for the two chips I'm using. Firstly, we've got the D-type flip-flop, 74HC574. I've used a 74HC series for everything that I've done with my CPU so far. And the block diagram of it is pretty simple. You've got 8 data lines coming into a flip-flop with a clock pulse to clock the data in, and an output enable to enable the 3-state outputs going out to the right. And I've permanently enabled that 3-state output, so it's just the data. If you put the data in, it shows up on the outputs. And the nice thing about this particular IC is that, where's the pinout? There's the pinout. It's the simplest pinout in the world. The data comes in nicely arranged down the left side, the data goes out nicely arranged down the right side, clocks down there, output enable over there, power and ground where you'd expect them. It's a really good IC. And the buffer at the other end is the 74HC541, and that is a very simple thing. It's just basically 8 buffers with 2 output enable pins that I've joined together, and they're the output enables that the Arduino is using to read the data back out of the register. And the pinout of this one again is very, very nice. It is all the inputs down one side, all the outputs down the other, 2 output enable pins, power and ground where you'd expect them to be. So it's again a very, very good chip. I've got another chip actually which I got first. I got an octal flip-flop with the pins all over the place, and I got a buffer with the pins all over the place as well. So these are very good ones actually. These are 2 that I'm going to be using a lot in my CPU.